Let's talk about a mental error so powerful it can lead even the smartest people in the world to make billion-dollar mistakes. It's a cognitive blind spot called the law of small numbers. And in this explainer, we're going to break down exactly what it is and, more importantly, how you can spot it in your own thinking.
Okay, so to get our heads around this, let's start with a real-world puzzle. A few years ago, researchers were looking at kidney cancer rates across all 3,141 counties in the United States, and what they found was, well, deeply confusing.
So here's the deal. The counties with the absolute lowest rates of kidney cancer, they all had a few things in common. So just take a second here. What kind of story does that immediately bring to mind for you? What do you think they looked like?
Okay, so here's what the data showed. The healthiest counties, they were mostly rural, sparsely populated, and tended to be in what we'd call traditionally Republican states in the Midwest and the South. Now, you can feel your brain just instantly start building a story, right? It's so easy to think, oh, okay, it's the clean, rural lifestyle. Less pollution, fresh air, fresh food, it makes perfect sense.
But, and you knew there was a but coming, here's the twist. The researchers then looked at the counties with the absolute highest rates of kidney cancer. And what did they find? The exact same thing. Yep, these counties were also mostly rural, sparsely populated, and in those same parts of the country.
Whoa. Okay, so wait a minute. How is that even possible, right? The same lifestyle can't possibly explain both the absolute best and the absolute worst outcomes. Something else has to be going on here. And that means that really satisfying story we just told ourselves about clean living, it's got to be wrong. The real answer is something our brains find, well, way less interesting.
Because the real explanation, it has nothing to do with lifestyles or politics or even pollution. It's all about statistics.
The one key factor, the thing that explains this whole paradox, is just that these counties have small populations. That's it. It's what you'd call a merely statistical fact, and our brains, which are absolutely wired to look for causes, find that answer so unsatisfying. But it's the truth.
And this right here brings us to the main event, the law of small numbers. It's basically this cognitive bias, this glitch in our thinking, where we expect a tiny little sample, like the population of one rural county, to act just like the big one, to perfectly mirror the average of the whole country. But statistics just doesn't work like that. Small samples aren't just mini versions of large ones. They're way, way more wild and unpredictable.
Okay, to really get this, let's make it super simple. Imagine we have this giant urn, and it's filled with marbles. Exactly half are red and half are white. Think of that whole urn as, say, the entire US population. And the red marbles are people who get kidney cancer in a given year. All right, so you reach into this urn and you start drawing out marbles. Now, if you only grab a small handful, let's say just 4 marbles, your chance of getting something extreme, like all red or all white, is actually pretty high. It's 12.5%. But here's the crazy part. If you draw just a few more, say 7 marbles, your chance of getting an extreme result plummets to less than 2%. And that's the whole point. Small samples produce these wild extreme results way more often. And those sparsely populated counties, they're just small samples.
Okay, so if the math is so clear, why do we fall for this trap all the time? Well, it's because our brains are built to be storytellers, not statisticians. We're wired to find causes, not to think about random chance.
The psychologist Daniel Kahneman has a great name for this. He calls it our System 1 thinking. It's that fast, gut reaction, intuitive part of your brain, and it is a machine for jumping to conclusions. It loves to take just a few little scraps of evidence, like rural counties, and immediately spin up this rich, coherent story. It hates doubt, it hates ambiguity, and it loves to see cause and effect everywhere, even when it's just looking at random noise.
And this love of stories, this search for causes, means we see patterns absolutely everywhere, especially where none actually exist. We have this deep, fundamental misunderstanding of what randomness actually looks like.
Perfect example. Let's say you're at a hospital and you're looking at the sequence of 6 births. Here are 3 possibilities. 3 boys, then 3 girls, 6 girls in a row, and then this more mixed up one. Okay, don't overthink it. Just go with your gut. Which one of these 3 sequences feels the most likely, the most random? Which one seems like it would actually happen?
And here's the surprise. They are all equally likely to happen. I know, it feels wrong, right? But because every single birth is an independent event, any specific sequence of 6 is just as probable as any other. The BGBBGB one just feels more random to us because our brains are such aggressive pattern seekers. We see a streak like 6 girls in a row and our System 1 brain just screams, "No, wait, that can't be random." But it can, and it often is.
And once you see this cognitive illusion, you start seeing it everywhere. It's the whole reason sports fans believe in the hot hand in basketball, right? A player hits a few shots in a row, and we're convinced they're on fire. But when you look at the stats over thousands of shots, it just doesn't hold up. It's the same faulty thinking behind the gambler's fallacy. You know, that feeling that after a string of reds on the roulette wheel, black is somehow due to hit. It's not.
Okay, so misreading a basketball game, no big deal. But let's look at what happens when this exact same simple math error gets applied to a massive, real-world problem with billions of dollars on the line.
So a number of years back, the Gates Foundation, among others, decided to pour a ton of resources into one of the biggest questions out there. What's the secret to a great education? So they crunched the data from all across the country, looking for the common traits of the nation's best-performing schools.
And what they found seemed like a breakthrough, a real game changer. The most successful schools were, on average, small. And you can just feel how compelling that story is, right? It's so intuitive. Of course, small schools mean teachers can give more personal attention, more encouragement to each student. It's a perfect, satisfying cause and effect story.
And based on this exciting, intuitive finding, the Gates Foundation and others invested an estimated, get this, $1.7 billion into creating new small schools and breaking up bigger ones.
But they had walked right into the exact same trap as the cancer researchers. They made the classic mistake of only looking at one extreme of the data. Because if they had just asked one more question, what do the worst schools look like, they would have discovered that bad schools also tend to be small. See, small schools aren't automatically better, they're just more variable. That small sample size, the small student body, just means their results are way more likely to be extreme, either extremely good or extremely bad.
So as you can see, this is a really powerful and potentially very costly bias. But the good news is, once you know about it, once you can name it, you can start to see it in your own thinking and guard against it.
So here are 3 simple things to keep in mind. First, be wary of stories, especially the really neat, tidy ones. When an explanation fits together almost too perfectly, that's your cue to be suspicious. Second, always ask about the sample size. Is this amazing conclusion based on 3 people or 3,000? And finally, number 3, just try to remember the role of pure chance. You have to accept that a lot of what we see, especially in small samples, isn't some deep, meaningful pattern. It's just random luck.
And that really leaves us with one final question to chew on. Think about it. That new person at work who had a couple of brilliant ideas in their first week. Or that new restaurant that was absolutely incredible the first 2 times you went. What are the obvious patterns in your own life that might just be an illusion, a simple accident of small numbers?